In this video, we're going to take a look at what happens when you have three or more parallel lines. So here we have our parallel lines, and we cut them with two transversals. Well, according to the proportional parts of parallel lines corollary, these parallel lines are cutting or transversals proportionally. And let's see what that means. It's going to be very clear when I show you the equation. Alright, so we have AB, which is right here, over BC, which is right here. So one part of that transversal over the other part of that transversal is going to be actually equal to that part, which is corresponding EF, over, and I'm guessing you probably can guess what comes next, over FG. So all the transversals do in this case is cut, or all the parallel lines do, is cut our transversals into proportional parts. So this over this will give you this over this. And this is only true if our lines are parallel. Okay, so here's another situation which is extremely similar to the one that we were just looking at. But in this case, we have congruent parts. So here we have that part being congruent to that part. Now, if we have those three parallel lines and we have congruent parts on one side, then or congruent parts of parallel lines corollary will tell us that we're going to actually also have congruent parts on the other side as well. So let's write that down. So if in this case, with the three parallel lines, if AB is congruent to BC, then in this case, EF will also be congruent to FG. And again, the reason for this is because we have those three parallel lines that are cutting this segment in half. So they're making congruent parts on this side. So it will also make congruent parts on this side. Okay, so let's take what we've learned so far and solve for x and y in this figure. So we already know from what the figure tells us that this and this are congruent segments. These two things are congruent segments. So we can go ahead and say that 3y plus 8 is equal to 5y minus 7, because again, those two things here are congruent to each other. Alright, so we want the y's on one side and the numbers, the constants, on the other side. So we can go ahead and take 3y away from both sides, and that will give us 8, which is equal to 2y minus 7. Now we can add 7 to both sides, and we get that 2y is equal to 15. And finally, we can divide both sides by 2 to isolate that y, and we get that y is equal to 7.5. Alright, so we were able to do that because we knew that these two things were congruent. However, we actually also know that these two things are congruent to each other. Why? How do we know this? Well, because we have three parallel lines being cut by two transversals. If these two things are congruent parts, that means that these two things will be congruent parts as well. It's what we just learned. So now that we know that, the rest is easy. So we can go ahead and set up our equation. Since this and this are congruent to each other, we can say that 6x minus 5 is equal to 4x plus 3. And again, we're trying to isolate our x, so we can get our x's over on one side. So let's take 4x away from that. And we have to do that to both sides. So we get that 2x minus 5 is equal to 3. So again, we're trying to isolate the x, so let's add 5 to both sides. And we get that 2x is equal to 8. And finally, let's divide both sides by 2. And we get that x is equal to 4. And that's how it works.